Hi friends, today we are going to see the third and last part of Newton's inventions. So be prepared and listen it peacefully. In this video, we are concentrating on his most famous inventions: optics, telescope, calculus, and he struck terror in the hearts of criminals. First, optics, science concerned with the production of propagation of light, the changes it undergoes and produces, and closely related phenomena. Physical optics deals with the nature and properties of light. Geometric optics deals with the formation of images by mirrors, lenses, and other devices that use light. The study of optics has led to the development of devices such as eyeglasses and contact lenses, telescopes, microscopes, cameras, binoculars, lasers, and optical fibers. Lens in optics, piece of glass or other transparent material, usually circular in shape with two polished surfaces, either or both of which is curved, and may be either, that is used to form an image of an object by focusing rays of light from the object. Newton publishes the first edition of Optics, a work summarizing his research in light and colors. Newton started his research into optics, or the study of sight and behavior of light, when he was a university student. Using a prism with light in a series of experiments, he studied the spectrum of light projected onto a wall. His analysis pointed to the existence of individual rays of light that refract at different angles, which results in phenomena such as rainbows. Believing that chromatic aberration or color distortion would always be present in glass lenses, his improved reflecting telescope and his theory of colors impressed the Royal Society in 1671-72. Next, telescope, device used to form magnified images of distant objects. The telescope is undoubtedly the most important investigative tools in astronomy. It provides a means of collecting and analyzing radiation from celestial objects, even those in the far reaches of the universe. Commonly known as refractors, telescopes of this kind are typically used to examine the moon, other objects of the solar system such as Jupiter and Mars, and binary stars. The name refractor is derived from the term refraction, which is the bending of light when it passes from one medium to another of different density, for example, air to glass. The glass is referred to as a lens and may have one or more components. The physical shape of the components may be convex, concave, or plane parallel. Derivation of light rays by lenses, that is, aberration. Division of light rays by lenses or curved mirrors, which causes the images to be blurred. Spherical aberration occurs because curvature in a lens or mirror causes rays falling on the outer edges to be brought to a focus at a distance point, spherical aberration occurs because curvature in a lens or mirror causes rays falling on the outer edges to be brought to a focus at a different point than those falling on the middle. This makes the images formed appear blurred. Chromatic aberration, which occurs in lenses but not mirrors, is the failure of the lens to focus all colors. The image appears blurred and shows rainbow-colored fringes around the edges. Lens, piece of glass or other transparent substance that is used to form an image of an object by converging or diverging rays of light from the object. Because of the curvature of its surface, different rays of light are refracted through different angles. A convex lens causes rays to converge on a single point, the focal point. A concave lens causes rays to diverge as though they are coming from a focal point. Both types cause the rays to form a visual image of the object. The image may be real, inverted, or photographable or visible on a screen, or it may be virtual, erect, and visible only by looking through the lens. This diagram illustrates the principle of refraction and the term focal length. The focus is the point or plane at which light rays from infinity converge after passing through a lens and traveling a distance of one focal length. In a refractor, the first lens through which light from a celestial object passes is called the objective lens. It should be noted that the light will be inverted at the focal plane. A second lens, referred to as the eyepiece lens, is placed behind the focal plane and enables the observer to view the enlarged or magnified image. Thus, the simplest form of refractor consists of an objective lens and eyepiece lens, as illustrated in the diagram. Microscope, instrument that produces enlarged images of small objects, allowing them to be viewed at a scale convenient for examination and analysis. Formed by various means, the image is received by direct imaging, electronic processing, or combination of these methods. The most familiar type of microscope is the optical or light microscope, in which lenses are used to form the image. Other types of microscopes use the wave nature of various physical processes, the most important being the electron microscope, which uses a beam of electrons in its image formation. Next topic, calculus. He worked out the fundamentals of calculus, though this work went unpublished for more than 30 years. Grew out of correspondence with Edmund Halley. Calculus, field of mathematics that analyzes aspects of change in processes or systems that can be modeled by functions. Through its two primary tools, the derivative and the integral, it allows precise calculation of rates of change and the total amount of change in such a system. The derivative and integral grew out of the idea of a limit, the logical extension of the concept of the function over smaller and smaller intervals. The relationship between differential calculus and integral calculus, known as the fundamental theorem of calculus, was discovered in the late 17th century independently by Isaac Newton and Leibniz. He discovered the binomial theorem and he developed the calculus that employs infinitesimal considerations in finding the slopes of curves and areas under curves. Newton was the original developer of calculus, an advanced branch of mathematics that deals mostly with the rates of change and problems such as determining areas or volumes within curved lines or surfaces. It is now well established that Newton developed calculus before Leibniz seriously pursued mathematics. Calculus is now the basic entry point for anyone wishing to study physics, chemistry, biology, economics, or finance. Newton becomes a professor of mathematics at Trinity College and writes on analysis by equation with an infinite number of terms. Fluxion in mathematics, the original term for derivative, introduced by Isaac Newton in 1665. Newton referred to a varying, flowing quantity as a fluent and to its instantaneous rate of change as a fluxion. Newton stated that the fundamental problems of the infinitesimal calculus were given a fluent that would now be called a function, to find its fluxion, now called as a derivative, and given a fluxion, a function, to find a corresponding fluent. The fluxion of the quantity y is equal to 3x square times the fluxion of x. In modern notation, dy by dt is equal to 3x square into dx by dt. Newton's terminology and notations of fluxions were eventually discarded in favor of the derivatives and differentials that were developed by Leibniz. Next, he struck terror in the hearts of criminals. Newton made an unexpected career change in 1696. He accepted an appointment as warden and later master of the Royal Mint, which was responsible for making England's hard currency. Newton served the mint until his death and took his duties very seriously, particularly when it came to counterfeiters, which he pursued with the kind of zeal that makes Batman look like a Boy Scout. Despite his advancing years, Newton showed the tremendous personal initiative bringing to justice. He infiltrated the underworld, personally cross-examined hundreds of suspects and witnesses, and almost single-handedly secured the conviction of more than 24 counterfeiters. Forging currency carried the death penalty at that time, and Newton was the merciless prosecuted to the fullest extent of the law. As warden of the mint and soon after master of the mint in charge of issuing currency, Newton oversees the replacement of the currency with new coins and relishes his authority in catching counterfeiters. Newton's reputation among his peers was marred by his unpleasant demeanor and was described as insidious, ambitious, and excessively covetous of praise and impatient of contradiction by astronomer Royal John Flamsteed. Newton dies on March 20, 1727 in London, England, and buried at Westminster Abbey. I am saluting his contributions for humankind. I hope people really interested might have enjoyed up to the end. They are requested to like, share and subscribe it. Thanks for watching.